Hello and welcome to the VHDL Introduction lecture. In this lecture, I'm going to introduce and briefly explain what is VHDL. So, VHDL, what is that? Well, it's a hardware descriptive language, and it's similar to Verilog. If you've ever heard of Verilog, VHDL and Verilog are one and the same. They're two different languages, but they're doing the same thing. We're describing hardware. It's a hardware descriptive language, hence the HDL and VHDL. And what that means is we're using VHDL to describe a hardware circuit. We're not actually writing software. So you kind of have to wrap your mind around the idea when you're working with VHDL, you're not writing software. It's not like a C code, Java, MATLAB, or anything like that where everything you write is happening sequentially. It's not that at all. What we're doing is we're taking and describing how we want a digital hardware circuit to operate. So we can think of it as we're architecting a digital schematic. So you'll say, okay, I want this specific AND gate, or do I want a comparator? Do I want some sort of digital, whatever type of digital thing you're wanting to do, you implement it and describe it in VHDL, and that's the whole idea behind it. And the big advantage of using VHDL is it's very portable. So if I have VHDL that I am running on, let's say a Xilinx or Altera device, I can take that same VHDL out as long as I'm not using specific components on the actual device, such as memory. That just means I have to change a little bit to use memory on the other device. I can take this one VHDL design and move it around to different logic devices on an FPGA, a CPLD, or any other type of logic device you might be using. And so that's one of the big advantages of using the VHDL. You can build up a library so that if you're creating a project with an Altera device, you can use those same designs when you create a project on a Xilinx device. You can use almost all those same designs on your Xilinx device. It's very portable, and that's kind of the whole idea and the whole reason that VHDL was developed. Was it takes a long time if you want to design something digital and you had to go and place new chips on a board that would require a new board layout, a new schematic, and it takes a long turnaround time. If you can just place one chip in the middle that's implementing all this functionality and you want to change it, such as your algorithm changes or you find a small bug, with an FPGA and VHDL, you can then modify your VHDL circuitry and reload it onto the FPGA, and now your design change has taken place without an actual board layout change. So that's one of the big advantages of using VHDL, or as we call it, configurable hardware. And the big thing to understand is it's not software. You're not writing software. Some of the constructs are the same. Some of the syntax and the structures are very similar, and they operate in the same manner. But what you have to understand is you're describing hardware, and that's the overall thing of what you're doing when you're working with the VHDL. Is you're not actually writing a software program. You're describing a hardware circuit. And where is a VHDL actually used? So it's used in several different ways, and the most common is it's used to configure, or we'll call it program, but you're not necessarily programming, you're configuring the circuit. But the CPLDs and FPGAs, or any type of configurable hardware device. And FPGAs versus CPLDs, they're similar in a lot of aspects, but typically your FPGAs are larger devices, and they're like SRAM based, where your CPLDs might be like EEPROM or flash based. So an FPGA doesn't contain its configuration. When you power off, you'll typically have to store that configuration on a memory chip off board the FPGA. So when you power on, it sucks in that configuration. Or like in this course here, we're going to just program it via JTAG. So once your FPGA is powered up, you'll program it or configure it, and you'll notice when you remove power and power back on, it loses its configuration. And that's because we just loaded it directly onto the FPGA, which is just RAM memory. So as soon as you power down, it loses all the configuration. Another reason you can use VHDL is to simulate digital circuits. So if you have a board layout you're working on, and you've got a section of several components, and everything they're doing is all digital, you can use VHDL to describe each one of those chips and how they interact with each other, so that you can simulate it on your computer And especially if you have like an analog and digital interaction, you can say, okay, I'm going to simulate my digital with VHDL, and I'll use PSpice to simulate my analog and verify that the interaction is occurring correctly. And another thing you can use VHDL for is to create an ASIC, or application-specific integrated circuit, which an example would be if you're working with a microprocessor, or say an ASIC that handles Ethernet communications, or a transceiver, or any of these types of ICs, integrated circuits. And if you work with circuit boards, or you develop any type of circuits, electrical engineering, you'll work with ASICs a lot. And when they're developing these, they'll use VHDL to describe the hardware that goes inside these ASICs, and they can use that to compile it and internally understand where they need to place all the gates for the actual chip to do the functionality you're describing. And finally, we're going to understand how are we going to be using VHDL. So in this course, we are going to use VHDL to configure programs on FPGAs. So we have these development boards with FPGAs, and they've got different peripherals on them: buttons, switches, LEDs, communication ports. And we are going to use VHDL to interface these different ports to each other, and just gain an understanding of how VHDL works and how we can use it on these FPGAs. So we'll be using these development boards, but the overall idea is we're using VHDL to describe a circuit inside the FPGA that'll explain how these peripherals interact with each other. So, and that is just a brief introduction and explanation to VHDL.